We're going to set up an experiment to demonstrate the transference of heat. We're going to apply heat to a couple of balloons and observe the result. When you apply heat directly to the rubber balloon, the rubber becomes very hot and weakens. In general observations, we've seen that when the rubber of an inflated balloon is weakened, the balloon will pop. In this experiment, we're going to apply the flame to the balloon filled with gas or air and a balloon filled with water. This experiment has several concepts that we will observe and need to understand. The first concept is heat. While we understand heat in a general level, the scientific definition of heat is energy that is transferred from one body to another as a result of differences in temperature. This is often referred to as the flow of heat, meaning heat being absorbed or heat being released. For this experiment, we will refer to heat as heat energy. The next concept we need to understand is heat capacity and specific heat. All objects, elements, and compounds have heat capacity and specific heat. Heat capacity is the number of heat units that are required to raise the temperature of a body by 1 degree Celsius. Specific heat refers to the amount of heat required to raise the temperature of 1 gram of a substance by 1 degree Celsius. For this experiment, we're going to address the heat capacity. For this experiment, we're not going to address the heat capacity of the rubber balloon itself, but rather the heat capacity of its surroundings. With the first balloon, the rubber is surrounded on all sides by gas or air, inside and out. The specific heat of the air is approximately 1.005 joules per gram per Celsius, depending on the altitude and humidity. For comparison, rubber latex has a specific heat of 1.6 joules per gram per Celsius. So the rubber can actually contain more heat than the air around the balloon. The second balloon is surrounded by air on one side and water on the other. The specific heat of water is 4.184 joules per gram per Celsius. That's almost 4 times specific heat of air. Let's take a look at what happens when we apply a heat source to the gas-filled balloon. As you can see, the rubber latex quickly reached its melting point, which weakened the rubber and the balloon popped. Now let's take a look at what happens when we apply a heat source to a balloon that's filled with water. Got lights in my eyes. As you can see, the balloon is not popped. Let's consider, why doesn't the rubber of the balloon weaken? Rubber latex, which is what this balloon is composed of, begins to melt at around 120 degrees Celsius. We also know that the boiling point of water is 100 degrees Celsius. That's the boiling point being the point where water turns from liquid to gas. Therefore, the water will continue to absorb the heat energy from the rubber balloon, which is being transferred from the flame, and the temperature of the rubber will not go above the 100 degrees Celsius. As long as liquid water remains in the balloon and the location of where the flame is in contact with the rubber or with the water, the temperature of the water will continue to slowly rise, though convection within the balloon will cause the warmer water to rise away from the flame and release the heat energy up higher. Therefore, the rubber will never reach its 120 degrees melting point and will not pop. And